So I made this problem up, drawing a skeletal structure from a chemical formula, to show you guys maybe another example of what might appear on your exam. When reading these, you have to keep in mind that anything that's in parentheses on like these outer terminals of the molecule is going to be, they're all of these, everything in parentheses is going to be attached to one carbon, but everything that's in parentheses in the middle is going to be part of the straight chain, or the long chain of carbons in the middle. So just looking at this, there's no way that all three of these CH2s over here in the middle are going to be attached to this carbon, because this carbon's already going to be attached to three methyl groups, and this is basically tert-butyl. So all of this is tert-butyl. So there's no way you're going to get something like this. And then this carbon would also be connected. So this carbon right here is this carbon right here, basically. And there's no way that carbon right here is going to be connected to all these methyls and then three more CH2s. That's just gonna be a complete mess. So you'll know that these methyls out here are going to make the tert-butyl right here at the end. And then this carbon right here is going to be connected to a one of the CH2s to complete its octet. So there's one CH2. And then you're going to make a chain for the second CH2. So there's 1, 2, and then now we have 3 CH2s. And now we look at the right side of this molecule. We have more things in parentheses on the end of it, on the end of a terminal, and not in between anything else. So we know that they're all going to be attached to the carbon right next to it, this one. So after our 3 CH2s, we've got this carbon right here with just a CH. And then it'll be connected to 2 methyl groups. And if you need, you can draw on your hydrogen to confirm that this is true. And so that should be the correct structure of this chemical formula. What you can do, I think, is count your carbons in the skeletal structure and the actual formula to see that they're the same. So anytime you have anything within parentheses over here at the ends of the terminals, it only counts as one carbon in the main chain. So count that as 1. Then you have this carbon here that's the that's in the tert-butyl group. So there's 2. And then that'll be 2 up here. And then 3 of these make 3, 4, and 5 in the middle. 3, 4, 5. And here's 3, 4, and 5. And then we have a 6th carbon here, the CH connected to the 2 methyls, or this isopropyl group over here. That's good to note. So that CH is going to be your 6th carbon. And we got 6. And then only one of these methyls counts in parentheses over here because it's at the end of the molecule. So 7 carbons in the main chain. And we see that these matches, so they're probably correct. Let me rewrite some things just in case you might find them helpful. Anytime you see this at the end, it's tert-butyl. So anytime you see that, keep that in mind. Anytime you see this at the end, it's going to be isopropyl. And hopefully if you do enough of these, you'll start to see these patterns of how these problems can be solved very cleanly and easily. Good luck.